Okay, we have a couple of quiz problems. The first equation. It's going to equal zero if this is zero or if this is zero. Okay. Next is zero property of multiplication. We solve this. So the solution is, well, you solve this, you get x equals 3/2. We solve this, you get x equals -3. And at this stage of the course, and actually pretty well from the beginning, everybody was really good at solving linear equations, so you shouldn't have any trouble solving that. Okay. And then we could write the solution set. It's the set -3, 3/2. I just chose to write it in order from the least to the greatest. But you could do it in the opposite order. Sometimes it's easier to keep track if you keep things in some sort of numerical order. But it's not required. Okay. Now, you got x squared plus 5x plus 6 equals 0. Yeah. Well, you factor that. Very easy to factor. You get x plus 2 times x plus 3 equals 0. So, same logic here. And I keep telling you, write out my words until you've got better words of your own. Okay? Because that will reinforce the zero property. Okay? Including the or. That's SOLN, short for solution. It's this or this, because it can't be this if it's this. It can't be this if it's this. Simple or, okay? The solution set. This is set. -3, -2. Now, -3 and -2. -3 and -2 go into the solution set. Because each is a solution, right? Okay. The ors and the ands is kind of important. Okay, well, the third problem. Factoring is hopeless. Worst things have been written used. Quadratic formula. Okay, so you're gonna get I times the square root of 7. Because the square root of -7 is the square root of -1 times the square root of 7, and I is the square root of -1. So the solution set is there's your solution set. Okay. Any questions on that? Very straightforward. And it only takes practice. And of course, you're going to have to know the quadratic formula on the exam, final exam. Now, I will comment that you could use the quadratic formula in every one of these. You could expand this as somebody did, and I think did it correctly, okay? And then you'll have 8x squared plus 12x minus 36 equals 0, okay? And you plug in your A, B, and C, simplify it, you get exactly the same, well, exactly the same numbers, okay? And I said what the square was, or the product in my head, I might have been right, but could easily be wrong. You got x squared plus 5x plus 6 equals 0, you can plug that into the quadratic formula. Okay, now, if I ask you to solve it by factoring, if possible, then I expect to see it factored, okay? On the final exam, if I say solve it by factoring, and you solve it by the quadratic formula, I'll probably give you half credit. You at least can solve it, but to get full credit, you're gonna have to factor it. And then this one just doesn't go to factor. You can test every possibility and find that you can't do it, okay? And on this one, you do need the quadratic formula, especially since the doggone thing comes out with complex number solutions. Okay. So, any questions on that? Okay, one last comment on solving the quadratic equation. This is real easy to factor. Factoring leads you quickly to a solution that's less involved than what you have to do with the quadratic formula. So you have less chance to screw it up. Okay. And then you always want to check your solutions at the end anyhow. And be, a lot of people made lower scores on their tests than they would have if they'd checked things. But people just run through and don't check. Okay. When you're doing your homework, check. Because here's your reinforcement. Of course, if you're doing it in open math and you got the right answer, and you know you got it. If you don't get the right answer, then it might be a good idea to check to get some idea maybe where you went wrong. But in the real world, open math is not going to be there to check it for you. Okay. So you gotta be checking for yourself. At least in some problems, if there are 15 problems, check 3 of them. So know what you're doing with checking. Okay. Just advice. But if you're on a test, by all means, check. It raises a red flag if you've made a mistake. Also, if you check and say, oh, darn, I know there's something wrong here, I don't know what it is, I'm going to be a little more generous with partial credit. Okay. Okay. Square of a plus b is a squared plus 2ab plus b squared. And we figured that out earlier. Multiply a plus b times a plus b, and that's what you end up with. And if it's not obvious to you, you ought to multiply that out every once in a while just to continue to convince yourself. Okay. If you don't remember what a plus b quantity squared is, well, just write it out. A plus b times a plus b, do the distributive law, and you're going to get it. Okay. And a plus b times a minus b is a squared minus b squared. And if you do the quadratic formula, you're going to have an a squared here, you're going to have a minus b squared here, you're going to have an ab here and a minus ab here. They cancel each other out, and that's what you're left with. Okay, we're going to just talk about how to use those two formulas. Factor. Okay, so let's say I've got now, if this is a square of something, then it's going to be of this form. Well, if this is of this form, then what is A and what is B? Okay, so, well, if this is a form a squared plus 2ab plus b squared, then the a squared should match up with 9x to the fourth. Okay. Now, what do you square to get 9x to the fourth? Well, 3. Now somebody's stuck on 3 there. Okay. And I said, well, okay, a is 3. Well, then a squared would be 9. Don't you need a little bit more? Oh, yeah, it's x squared. Because you square x squared, you get x to the fourth. Okay. And b equals, well, if b squared is 16, then I guess b equals 4. Let's see if this works. Okay, of course, you understand the squaring 3x squared plus 4 is this. Now, of course, we've identified a and b, and we're trying to get something of the form a plus b quantity squared, right? So if this is this, if this is of this form, then it's got to be this. Okay, because your a is now 3x squared. Okay, again, we look at it. A squared has to be 9x to the 4, so a has to be 3x squared. B squared has to be 16, so b has to be 4. Now, then we at least hypothesized that this would be 3x squared plus 4 quantity squared, because if a is 3x squared and b is 4, this is what we get. So we expand this. And what do we get? We get 9x to the fourth. We get 4 times 3x, which is 12x. And this 4 multiplies 3x, which gives us another 12x squared. 4 times 3x squared is 12x squared. And this 4 times 3x squared is 12x squared. So we get 12x squared, and that does match up. 12 and 12 is 24, we get 24x squared. Okay, and that does match up what we have here. And then plus 16. This checks. Okay, so we've concluded that this equals, write it in a different color. X squared plus 4 quantity squared. Now, if I'd have written down 9x squared plus 25, 9x to the fourth plus 25x squared plus 16, it wouldn't have matched. Because this term and this term determine what this one has to be. Because, of course, square root of this and the square root of this are what go in here. Okay? That makes sense? Okay. And then we've done an example like this, but let's do another one. Let's say we've got 64x to the 12th minus would be 25 y to the 6th. Is this in the form a squared minus b squared? Well, any two terms you subtract are of that form. It's an a squared minus b squared, where a is just the square root of this, and b is just the square root of this, right? So I would ask you to write out all my words here and then fill in the blanks. Okay, well, in this case, if this is a squared minus b squared, then a squared is 64x squared. So a would be the square root of 64x, not squared, it's x to the 12th. Now let me rewrite this a little bigger. To read it. I wrote out all the details, but you could see visually, everybody saw it visually. The square root of that is 8x to the 6th. Okay. It'd be 5y cubed. So, Okay. Now let's do an easy one. Well, I can use special product. Solve this equation. And actually, it doesn't have to be equal to zero. We can use the zero property so much, I kind of just automatically wrote that down. Let's say equals 72. Okay, so what we're trying to do is use a special product to solve this equation. And well, the equation again is this. Okay, now if this is in the form a plus b squared, then it's very easy to solve this equation. The fellow that a is this and b is this. And let's go ahead and write out. Okay. Now, in other words, is this an a squared plus 2ab plus b squared? Because if it is, we can write this. Okay, well, if it's so, then a equals this and b equals this. And then your 24x would have to be, of course, your 2ab, right? Well, 2ab equals 2 times x times 12, which is 24x. X, not b. So the b there, I wrote it down here. Okay. Thus, our equation becomes x plus 12 squared equals 72. Okay. X plus 12 is plus or minus square root of 72, which is and that's 6, well, it's plus or minus 6 times the square root of 2. Now, I just heard somebody say Appalachian. You're not allowed to say Appalachian in Southwest Virginia. Somebody has to edit that film. Appalachian. I came from the north. I got corrected in that real quick by one of my colleagues. It's Appalachian. Okay. So Appalachian just doesn't sound right to me anymore, even though that's what it's pronounced. First quarter of my life. Okay. Okay, so anyhow. I need to. I don't know who that guy is, but I find his voice irritating. I didn't notice it until he said Appalachian. Okay. Okay. Anyhow, this equals this, right? I've just repeated this without all the intermediate steps. So we subtract 12 from both sides and we get this. And that's identical to what you would get if you used the quadratic formula. You could subtract 72 from both sides. And then plug your A, B, and C in, and you get exactly the same thing. But this is a little slicker. Okay, now I would say if you have an equation like this, write out all these words. Get it into your head because it's a good trick. But then once you got it in your head, if you can recognize this is of this form, it makes the solution a lot simpler. Okay, well, something else we need to talk about now. It won't be due before the next class, but it'll be due over the weekend. There'll be 2 assignments. Over the weekend, we want to start talking about this first one. And it's relatively simple if you can do the factoring. Okay, so let's say you simplify that. Okay, no, we're in a little short on time, so I'll shortcut this in. Some people still working, but we can verify that this factors, and everybody knows how to factor. Numerator factors into x plus 2 times x plus 3. The denominator factors into x plus 2 times x plus 2. You might even notice that that's an application of the special product, and it's x plus 2 squared. But we want to write it out as x plus 2 times x plus 2, so we can see for sure what's happening here. Now, if you've got this, what's the obvious thing that you can do to simplify it? Okay, now, people want to cross a line through this and a line through this and say they cancel. It's actually right, but I don't like to do that because people will draw a line through this, get a line through this, and then they'll go back the last 6 pages they do and cross out every x plus 2 they see there because they don't understand what they're doing. Now they won't actually do anything quite that bad, but people will cancel out, people will draw a line through this x and this x, thinking that they cancel. Okay, that's not unusual at all. I see things like that a lot. Or they'll cancel this 2 with this 2 and leave the x and x. Okay, and then the x's can't only get x plus 3 over x plus 2. It's wrong. Okay. This equals this, isn't it? And if you multiply this out, you multiply the numerators and you multiply the denominators. When you multiply the numerators, you get this. When you multiply the denominators, you get this. That makes sense. I mean, you might be so busy wanting to draw lines through things, it's hard for you to see that, okay? And then x plus 2 over x plus 2 equals 1. Times x plus 3 over x plus 2. And that equals x plus 3 over x plus 2. Okay? That's the same thing you get if you draw a line through this one and this one, then rewrite it. But it's using valid algebra operations to get from here to here. And crossing things out is not a valid algebra operation. It's a shortcut that people do wrong. Okay? I don't think people here today would do that wrong. I don't think most of the people, and I haven't yet seen everybody's midterm exam, but I don't think most of the people in the distance section would do that. But there's a tendency to do that, just like there's a tendency to say x plus 2 quantity squared is x squared plus 2 squared, when it's x squared plus 4x plus 4. Okay. Okay. There are things that look right that aren't right. I mean, you cross out all the x's, you got an x here, but cancel this one, an x here, but cancel this one, and end up with 2 times 3 over 4, which is 1.5, which has nothing to do with this expression. Okay. So you're going to use cancellation. Be sure you know the rules. And the rule is you're dividing this into this. It gives you 1, and that leaves you this. Right there are all the steps that show that. Okay. So anyhow, that's it. And you got a bunch of expressions in the homework, much like this one, that you factor, and then divide out common factors. I don't use the word cancel, I say divide them out, because that's exactly what you've done. Okay. There's another thing. As long as x isn't -2. Why do you have to say x can't be -2? Well, if x is -2, what's x plus 2? 0, right? Can you divide by 0? It's undefined. It doesn't exist. Okay. What I'm saying, this is okay as long as x isn't -2. Because if x is -2, when you did this division, you just divided by 0. -2 plus 2 is 0. That'd be -2 plus 2 be 0. What's wrong with dividing by 0? You can't. since we're in Southwest Virginia. I grew up in Northeastern Ohio. My best friend said he'd get frustrated because he couldn't do something. He'd just say, "Oh, I can't." So I'm harking back to my best friend from over 60 years ago. So he could do a lot of things. He was a good athlete. He and I have football skills that if you put together, he had a pretty good football player. As it was, we were both pretty mediocre, but okay, you get the idea, right? Okay, well, we're right on the dot. Time for me to stop.